Okay, we're going to get into the grounding electrode system 690.47. But before we do that, I just want to just cover one point. We were just discussing about bonding modules to racks, right? That was 43A, and then B about the racks. And then we go to, I think it was 45, about the equipment grounding conductor and the size of the equipment grounding conductor. What we're trying to do is this. We're trying to take all the metal parts of a PV system. We want them to be all electrically connected together. And the way we achieve that is the bonding of the weaves and the bonding of the UL, whatever that number was, and that gets a bonding. But we have to connect it ultimately to the earth. We have to ground the equipment. It's called the equipment grounding. We want all metal parts in a building to be bonded together, connected to the earth. So we're going to be running an equipment grounding conductor out over to, from the AC side, electrical grounding electrode system. We take an equipment grounding conductor out to the circuits like you normally would, but I just want you to realize that on the DC side, we're trying to make sure we connect those all metal parts back over to the AC side so that ultimately the metal parts are going to be grounded. That's why it's called an equipment grounding conductor. Now, and it could be used to carry fault current. Not much fault current on a transformerless system, but I mean, it's carrying current, right? And if you start getting into AC circuits at 120 or 240, whatever it is, we're carrying a lot larger currents, okay? Now the equipment grounding conductor is serving two purposes. One, for the purposes of bringing everything back over to the earth for equipment grounding, but it's also serving the purposes of having the low impedance path necessary to facilitate the clearing of a fault, because it's part of the effective ground fault current path. Now, some of us, for a while, and the way the code was for many years, it was kind of confusing because the code implied that what you really wanted to do was to ground things because it assisted clearing a fault, it brought everything to zero potential. So grounding was a big deal. And then once we started realizing, wait a minute now, grounding is for equipment, metal parts that discharge that energy, and sometimes you might want to ground a system, but this is never for clearing a fault. Utilities is a different story, okay? So then we started saying, well, then we shouldn't be using the word ground for that wire, that green wire. Let's call it bond. 2000 A code, between 5 and A code, had a committee, went all down the line. There's been proposals after proposals, even myself saying it should be called an equipment bonding conductor. And I said, Mike, or industry-wise, it's serving the purpose of grounding, which means you bring it to the earth to discharge that charge on there. And what they did, and they added in the 2000, I think it's either 11 or 14 code, I think it was 11 code, they said it also serves the purpose to assist in basically clearing a fault. So we have to keep the word equipment grounding conductor. So those of you that was wondering about what should be an equipment bonding conductor, because it does serve the purpose of equipment bonding. And actually, let's go into 250. Let's go to Article 100, and let's go to equipment grounding conductor. So you can see the change that was made, or not made recently. Oopsie. There we go. Grounding, I guess it's called grounding equipment. The conductor paths that provide a ground fault current path, that's your ground fault current path. That's your fault current. And connects normally non-current carrying metal parts of equipment together and to the system grounded conductor or to the grounding electroconductor or both. So what do you guys do in your PV? You bond all your parts together, you bring an equipment grounding conductor, you go out there, we're done. We don't do any extra electrodes, we're not grounding any DC system. It's an equipment. It's inherently done by the mechanical connections and the electrical connections that we are required to do. Let's take a look at the language here. And as we can see, is it completely revised, Bill? I mean, like completely everything? There's some new stuff added in there. Basically, the whole thing is new. All right.
Yes.
I think you guys actually have done a fantastic job on this. So let's just kind of step through it real quick here. A building or structure supplying a PV array shall have a grounding electrical system and installed in accordance with Part 3 of Article 250. Now, that means that when you have a PV system, the array itself must be connected to an equipment grounding conductor for equipment grounding and connected to an electrode. If you have a standalone system in a building, then there would be no electrode at that building. We're going to have to add an electrode to connect it to that standalone system. If you have an array on a building that already has an electrode, well, therefore, there is no problem because the array is already connected with an equipment grounding conductor, connected to the electrical system that's connected to an electrode. In the previous editions of the code, it required us to add another electrode to a building that already had an electrode, which would make no sense because it's already connected to the equipment grounding conductor. Like even a ground-mounted system. A ground-mounted system, a bunch of arrays on a ground-mounted system, you would not be adding ground rods to the individual ground-mounted system because they're connected with the equipment grounding conductors that ultimately get back over to wherever that the equipment room is going to be, and there's going to be a grounding electrode at that location. So you need one electrode for the electrical system. And if there is no electrode at all, standalone system, you're going to have to add an electrode. Let's go on now to additional text. PV array equipment grounding conductors shall be connected to the grounding electrode system of the building or structure supporting the PV system in accordance with Part 7 of Article 250. Well, yeah, I mean, of course you got to comply with Part 7 of Article 250 because Part 7 is in 250 and Chapters 1 through 4 apply, but we've learned this. Mike, let's just kind of remind the guys about what's going on. And that means you run your equipment grounding conductor in the circuit conductors and you make sure you size it proper and you connect it where? To the equipment grounding conductor. Well, yeah, because that's part of the equipment grounding conductors. And the AC circuit has an equipment grounding conductor, goes to the DC circuit, it's all size in 250/45. The connection shall be made in addition to any other equipment grounding conductor requirements in 69043C. What was 69043C?
With the other conductors, with the circuit conductors.
Oh, okay. Hey, in addition, comply with that, with the circuit conductors. The PV array equipment grounding conductor shall be sized according to 45. In case you missed it, just reminding you, 43C and 45, just kind of get you back in there. For PV systems that are not solidly grounded, which is our functionally grounded systems that you guys taught me about, which are different types of systems that are functionally grounded. I didn't realize that. The equipment grounding conductor for the output of the PV system, which is the inverter AC output, connection associated to the associated distribution equipment shall be permitted to be the connection to ground for ground fault protection and equipment grounding conductors, which is exactly what we're talking about. I mean, your equipment grounding conductor, everything in the building is connected to the equipment grounding conductor, and the equipment grounding conductor, the PV system, that equipment grounding conductor is the connection that provides you the connection to the grounding electrode because we are grounding the equipment. So it makes it perfectly clear. For solid grounded systems, I'm not going to talk about that. No reason to get into that. Now, I think you guys did a fantastic job on this informational note. Most PV systems installed in the past decades are actually functionally grounded systems rather than solidly grounded systems as defined in this code. For functional grounded PV systems with an interactive inverter output, the AC equipment grounding conductor is connected to associated grounded AC distribution equipment, right? I mean, you take the breaker, you hook the equipment grounding conductor. This connection is often the connection to ground. Well, it's the connection to the equipment, and the equipment is connected to a grounding electrode conductor, which connects to an electrode, which makes the connection to the earth for equipment grounding. It's a connection to ground for ground fault protection and equipment grounding of the PV array. So your ground fault protection, that equipment grounding conductor for ground fault protection because you're bonding it together, but it's also the connection to the electrode. You guys did a great job. You bond everything together according to listed products. We got that taken care of. You bring an equipment grounding conductor like you normally would. We're done. This is not any other magic involved inside here. Now, would have additional electrodes. Now, you know, and I'll get started. For the longest time, the industry, with I think the influence of the electrical guys, because they want to see a ground rod to everything, and they don't understand what's going on inside here. And man, we know grounding makes it safe. It brings everything to the same potential, assists in clearing a fault. Electrons are going to ground. They're taking the path of least resistance. They want to get a ground. And these guys are driving me crazy because I've been teaching grounding. I'm learning how it all works inside here. And so what they would actually require, they actually required an electrode to be installed at a building that already had an electrode, and they wanted to run a wire from that electrode over to the array. That's like, gosh. Well, so what do you have to do? Well, you can't like pull the rug out of everybody and say you guys are all wrong. So you say, you know what? I tell you what we'll do. We'll leave a rule in there. We'll say, if you want to, you can add an auxiliary electrode, and you can use an electrode of the type recognized in 250-52, or and if you want to, you can go ahead and add it, and you can make a connection, and it's not a violation of code. This is not newfound language. As a matter of fact, this is contained in signs. Let's take a look at signs. 600 dot, I think it's 7. It's hard to remember those kind of rules. Okay, wrong button. Grounding and bonding. Okay, here's what 600.7 says, having to do with signs. Very similar to what you guys did in 690. There are people out there, not many, but there are some people out there thinking, well, we better put a ground rod in that sign because if lightning strikes the sign, you're going to have lightning protection. So they said, okay, tell you what, we're going to give you some rules about auxiliary electrode. An auxiliary electrode shall be permitted for the electric sign and outline lighting system covered by this article and shall meet the requirements of Article 250. Okay, you want to drive a ground rod out there, it's fine, recognizing you go to 250.94. 54. Now let's go back to 690.47b. You guys did the same thing because you can't tell them, you don't want to tell them nothing, you got to, because then they're getting all stressed out. You got to say, listen, tell you what. An auxiliary electrode. Now an auxiliary electrode, just so you know, 250.54, they wanted to call it a superfluous electrode. Actually, that was one of the proposals, call it superfluous electrode. This is something you don't need. As a matter of fact, if you read the language in 250.54, it's one of the few rules that tells you what you don't have to do. An example, there are rules, I think I forgot where it is in 250, that tells you that you don't have to comply with the burial depth of the grounding electroconductor that's contained in table 300.5. And the reason they have that in 250 is because people said, hey man, you got to bury that grounding electroconductor. They said, no. The next cycle comes around. Bruce, give me full screen. You got to bury that grounding electroconductor. And the co-panelist says, no. They finally did what, Bill? They said, you know what, Tom? Let's just write a rule saying you don't have to bury the grounding electroconductor. And so that's what they did. So you have some rules that people are so bent on wanting something that's not required that you actually have to have a rule to tell them it's okay, but it's not required. And that's what we have in 690.47b, because you got that history of people that want to see a ground rod, they want to see the array, they're all stressed out, and that's what B. And you notice B is brand new, and let's not new in the sense that it's new, but it's just language. Here we go. Grounding electrodes shall be permitted. I'm done. I'm stopped. I don't have to read anymore. You can, but I don't want to. Okay, then you don't have to. But if you want to, can be installed. You could install it in accordance to 250-52. It's a couple ground rods. You could do whatever. Or 54.
And
54. And then 54 tells you what? We don't care what you do. So you could.
You don't have to bond it.
yeah.
And you don't have to bond it. You could do whatever you want to do, but you don't have to. At the location of the ground-mounted roof arrays. So if you have a ground, okay, but whether
Wherever you want.
Wherever you want.
this is an example where the code in some of our it says metal and non-metallic raceways. Well, aren't they? How about we just say raceways? Okay, at locations, a ground-mounted rooftop. I mean, how about we just say at a race? Okay, you can, if you want to, put an electrode according to 52 and 54, if you want to, and connect it to an array. Then it goes on. The electrodes shall be permitted to be directly connected to the frames or the structure. If you want to, connect it to whatever you want to connect it to. We don't care what you're going to connect it to. The electroconductor shall be sized in accordance with 250.66. But now, if you choose to do something that's stupid, we want you to put a big wire in 250.66. We're going to shove it to you, okay? You're so stupid you're going to do something like that?
Minimum number 8.
Minimum is like what? 5?
Number 8.
The minimum is number 8. You get 8 gauge. Now, the structure of a ground-mounted array, which you can connect to electrode if you want to connect to electrode, and you can use 52 and 54 if you want to, the structure of a ground mount array is permitted to be considered a grounding electrode. So the actual mounting, hey listen, I want to ground my arrays, but you don't have to. Yeah, I don't have to, I want to. Hey, by the way, since you want to ground the arrays, let me give you a hint. The metal supports that you're putting in the ground, those can be your electrode. And so therefore, you got a chance to achieve what you wanted to achieve that makes no sense to do anyhow, because you want to ground the arrays that you don't need to ground arrays to an electrode, and the mount that you're installing them can be the electrode that you use to ground the array, and so therefore, you're done. And you actually did it anyway.
By accident.
By accident.
You're so
Man,
good.
that's called the law of compensating errors. Okay. If it meets, okay, roof mount arrays are permitted if you want to use the metal frame of a building or structure. You got a building, an entire metal building, metal structural steel, the whole thing, and you want to mount it on the roof, and I want the array to be connected to the earth. Connect it to the metal building if you want. So basically, I think you guys did a phenomenal job. To me, it makes it perfectly clear. And let's go to some slides. Okay. And building a structure supporting a PV array must have a grounding electrode system installed. Well, it always has a grounding electrode system installed. Well, not always, Mike. You got standalone. Okay, fine. You're right. Forgot about the standalone. You're going to have to put one for the standalone. Okay. PV systems that aren't solidly grounded, the equipment grounding conductor, right over here, for the output of PV AC system connected to the distribution equipment, which of course is connected ultimately to the grounding electrode, can provide the connection to ground for the ground fault protection and the equipment grounding conductor. In other words, whatever you do is automatically done. Perfect. Now, you are permitted to go ahead and take the array and connect it to the earth. And you can put an electrode that, if you want to, I mean, you don't have to comply with 52 and 54, but if you want to comply with 52 and 54, and if you want to connect it to the array, hey, you want to put a 16-penny nail on the bottom and run some fixture wire? Perfectly fine, too. I mean, it doesn't really matter. But you can comply with 52 and 54. And now, the reason we don't want to do that, though, we really are not looking to be taking arrays and connecting them into the earth while the array is already connected to the earth. I mean, it's not a good idea, because now you're going to get the possibility of currents traveling between when there's an indirect lightning strike. A direct lightning strike striking this array on top of a building with a wire connected to the earth is going to do squat. You're still going to have a fire, you're going to have a problem. That doesn't solve the problem. Now, you have a ground-mounted array. Well, you don't need to connect the array to the ground, but you are permitted to take the array to the ground if you want to. And 47B says that the metal mounting of the array itself could serve as the electrode if you wanted to do that. And 250.52A8 just simply says any metal structure in the ground is considered suitable as an electrode, which is part 3 of Article 250, and it's also part of 250.52. So there's no reason to be doing anything, but if you wanted to do something, then it's already done. So you have all these devices sitting out there. Man, let me tell you something. How many square inches do you think, if you were thinking that you wanted to ground for some reason, take the square inches of all those little puppies and put them together? You don't add a ground rod. So if you're thinking, I want to make sure grounded, listen, come on, think about what you've done. It's already done. If you thought you wanted to do it, you're good to go. And of course, we talked earlier about fencing. You know, fencing is if it's not part of a substation, then of course you would never drive a ground rod, because that never serves a purpose, ever. But if you're part of a substation, well, that's a different story. IEEE 80. You know, it gets into all kinds of things, bonding and grounding and connecting and fence posts and the swinging of the gates and the separation, how far you're going to put the wires and bonding and like that. But this is not a substation. This is just simply an array inside here, and, you know, we talked about that. So, but it doesn't hurt. This is what is called an auxiliary electrode, something that you don't need to have. And anytime you want it, you can put a ground rod next to your car if you want to. I mean, it'll be perfectly fine too. But that's about what it's accomplishing here. Okay, I'm done with the grounding, but let's see if there's any comments that's not going to make it complicated. David.
I just wanted to clarify something. Right before we were talking about the GECs, we were or earlier we were talking about the light posts and how you shouldn't be putting a ground rod at those. And then
No, I didn't say the light posts. There's nothing wrong with driving. Let's just back off to electrical. And we had that example. Here's the practice in the industry for years, before I started explaining grounding and bonding and changing and how the code changed. They used to run 2 wires, electrical conductors, out to light posts, and they drove ground rods.
Right.
Because they wanted to make sure the post was safe. Now what happens is they still drive ground rods because that's the way the 2 fingers work, right? We just always do it that way.
Right.
But now they bring in equipment grounding conductor out there. And by the way, at IDOT, I told you a story about IDOT. I did the seminar and everything like that. And when I looked at the guy who I taught, I said, now you're wiping out that design of the ground rods at every single piece of metal of the traffic signals. He goes, no, we can't do that. We got to keep the grounds. In other words, because they've been doing it. So my problem with ground rods in place that serves no purpose is it gives people the impression that somehow it actually serves a purpose. And then when they get into some dilemma somewhere, they're thinking, okay, you know what? Let's just put a couple ground rods. I know I said that to myself at times. So you can put a ground rod at a pole. That's not required with an equipment grounding conductor. There's nothing wrong. It's an auxiliary electrode. So I want to clarify it. Now, say what you're going to say.
Right, and then my point was for the picture that Brian had showed where you had the 2 PV panels on top of that light post, that was probably a standalone system, so that'd be a case where we actually would have to have the ground rod there.
Okay, you're saying, hey, listen, we had a solid grounded system on top of a pole. Okay, well, you need an electrode to that building a structure. Right?
That would not have been served by the utility system.
And that was not served by the utility system, so yes, in that case. Now, I don't know what size, if we need to be covering size, a little 200-watt array. Would it serve any purpose to ground that to the earth? No, lightning is not going to do anything like that. We're not inside of a building and they have metal parts in the building. It's going to build up a big charge. It's going to try to static discharge inside us like that. I would not. It would serve no purpose. I would not do it. But if you told me, Mike, it's a separately drive system, like, yeah, Mike, if you go to 690.47, building of structures, okay. So yes, I agree with
It's
you.
just the initial application, but we had just kind of laughed about it when we seen the
exactly.
ground, talked about the ground rod there earlier, so I want to make sure that was clear.
Then you say, well, you need it. Like, okay, you're right.
And if you listen to the recording, there were some side comments made while that picture was up, which were to that.
But they were all mumbled.
They were all mumbled.
Yeah.